So next up, I'll be giving a talk on Vert.x. And for you guys that don't know me, just please call me Taz for short. I just prefer going by Taz. Like Tasveer is just way too long. So anyway, for those of you that don't know what Vert.x is, yes, I'm doing this presentation in Vim. Sorry for the lack of syntax highlighting. Everything's white. But I think we'll deal with that anyway. So anyway, if you guys don't know what Vert.x is, Vert.x is a lightweight, a high-performance application platform for the JVM that's designed for modern mobile web and enterprise applications. So to me, that's a bunch of business talk. So let's scroll down here and how does it actually work? So there's really two things in Vert.x. Oh, and my Vim is scrolling. There we go, that's a bit better. So how does it work? So there's two things in Vert.x. Really, there's a vertical and there's modules. So a vertical is really just a package of code. It's just some code, and we'll get to that in a little bit. They can execute concurrently, so you can have multiple verticals running at any given time. And a module is really just a collection of verticals. Oh, sorry, and a vertical can also cross network partitions. I'll get to that in a bit later on as well. So what does a vertical look like? So this is a vertical here. It's a pretty simple vertical. We have a server. We require a Vert.x. We create an HTTP server. We add a request handler, and we simply just respond on port 8000 with Hello Toronto JavaScript. So I'm a big fan of showing the code and showing what the framework is like. So throughout the presentation, I'm going to show you what it's actually running with. So we're going to run this with a simple vertical JS. Let's paste that over here. And if I bring up another tab, I can curl that. Oh, it's a really small font. We can curl that on, it's over here, so it can save me the typing. There we go, Hello Toronto JavaScript. Cool, awesome. So it builds the world's most simple vertical. Okay, cool. So that's all cool and all, but it looks like it's an event-driven. And we just had this big discussion about events. Let's delve a bit deeper into what it is to be event-driven. So, it is. Cool. So event-driven architecture. So what you do is you define handlers that respond to events. So as Matt and someone else in the audience mentioned earlier, DOM events are a great example. You have an on-click handler, that responds to the on-click. You have an on-load handler that responds to on-load. We're all JavaScript developers. I don't need to go too deep into this, but you just have a handler that responds to an event. Cool. And then you have this event loop. And what the event loop does is it asks, are there any events? If so, call the handler for that event. So the handler goes off and does its thing, and eventually yields back to the event loop, and goes back up to step number 1. So it's just a constant loop, check if there's events, and if there are events, call the handler, handler does its thing, comes back to the event loop. Advantages and disadvantages, well, in order to talk about what the advantages and disadvantages, we have to talk about something else to compare it to. So in order to compare an event-driven architecture, let's compare it to a multi-threaded architecture. So in this case, threads are units of parallelized code that execute concurrently on a system. And the system schedules these threads. So you have a bunch of these threads, and the system's responsible for how it schedules and how they all execute together, and so on and so forth. So now we have something to compare it to. Let's compare it. So what are the advantages of an event-driven system? So with an event-driven architecture, you can put a lot of events on this event loop. It can handle tons and tons and tons of events. It's great for I/O-bound applications, such as web apps. And our good friend Abhi, as I mentioned earlier, is wearing an awesome Nginx shirt, which is event-driven, and it's an HTTP server. So it's a great use case for event-driven applications. Because you can really, for every web request coming in, you just add another event. For every WebSocket connection, you can just add another event, and then the event loop will just get to it when it gets to its turn. So in order to be concurrent, you can spin off multiple processes, multiple event loops, and you can do things concurrently. And because of this, event handlers are generally single-threaded, so you don't have to worry about thread safety. The disadvantage is, since it's multi-process concurrency, you have to share data between these processes, which get annoying. And sorry, guys, I'm sure this is the most neckbeardy part of this presentation. And I'll get to the fun stuff in a bit. So anyway, you have to worry about sharing data between these processes, and handlers can block the event loop. So what I mean by that is, if you have an event handler and you decide to calculate Fibonacci in that event handler, it's going to, it's not going to yield back to the event loop. It's not going to get to any of the other events that are queued up. So your application looks as if it's stuck. It's just in that state, and your app becomes unresponsive. So multi-threaded advantages, you can execute in parallel. So all these threads are executing at the same time. It's great for parallelizable CPU-bound applications such as calculating Fibonacci. You don't like it doesn't block. So if you calculate Fibonacci in one thread, it's not going to block the other one. They can both happen concurrently, and data is shared. But it can also be a downside. You have to constantly worry about thread safety. The disadvantage is the system needs to schedule all these threads. So if you have the example of the web server again, you have like 100,000 WebSocket connections, and you spin off a thread for each and every one of these. Your system needs to schedule 100,000 threads. That's going to be expensive. It's going to take a while. Your system's going to slow down. You're going to see the system indicator of your CPU just go up, and you have to worry about thread safety, sharing data between threads. Cool. So now that we got all of that out of the way, we can get into what does Vert.x do? Because this talk is about Vert.x after all. So what Vert.x does is it has multiple event loops. So you have all the benefits of an event-driven architecture, but you don't have the blocking downsides of a single-threaded, where you don't yield back to the event loop. So you have one event loop per CPU core, and that's really its own thing. Verticals are then distributed across these event loops. So if we were to deploy, let's say, 10 of our simple verticals, so you can deploy them programmatically or via the command line. We're going to do it via the command line in this case. So over here we have our simple vertical running still, and we're going to do an AB, an Apache bench on it, and we get around 1,500 requests a second on a single one. Cool. So theoretically speaking, if we spin up 10 of these, we should get more throughput. Let's give that a shot. So there we have 10 of them. Just FYI, OS X rather doesn't have the best networking subsystem. Linux has a better one. So generally, due to file descriptors and other things that really someone with a neckbeard should be explaining to you, it doesn't perform as well as Linux. So please bear with me here. So anyway, that's our first run, and we already have more, right? We already have around 3,000. If we keep doing this, we should get more and more. Around 5,000, and more, 5,500. So anyway, like you can sort of imagine, in order to scale out this application, all we have to do is throw more instances at it. So there we have 10, and it's faster. It can handle more throughput. Cool. So that's how Vert.x handles. It has an evented architecture, but it's multi-threaded, so it can sort of do both. You don't really block the event loop. It's very easy to scale. It's very easy to just bring up more instances. So that's great, but I mentioned that it crosses network partitions earlier. So how does it do this? So Vert.x uses Hazelcast behind the scenes to connect event loops into a cluster. So for those of you that aren't familiar with Hazelcast, it's sort of like Erlang. For those of you that aren't familiar with Erlang, it's sort of like telecom-grade concurrency. That's what powers your phones and stuff. It's crazy distributed stuff. So what Erlang does is it has these actors. And an actor is a small little unit of code that communicates to other actors via message passing. And I can show you an example of this in a little bit. So if you want more concurrency, just add more actors, and then you've scaled your system just by adding more actors. And that's sort of what I did earlier by just spinning up 10 of them instead of one. Just add more of them, and you get essentially more throughput, more scale. And the benefit of this is code can easily be hot swapped without stopping the entire system. If you have a new actor, you just add that to the system, bring out the old ones, and you've swapped your code perfectly fine without stopping the entire system. So what does all this mean? So let's define a handler on the event bus. So here we have Vert.x, we have a console, we have our event bus, and we're registering a handler as a polite handler. That's the Canadian in me, being the polite Canadian that I am. It's going to take in a message. So this is really the message passing I was talking about before, and it's going to respond with a replier. So in this case, it's going to say hello from JS. Cool. It's going to log that it's registered down there. And we're going to create a HTTP server once again. So same thing we did before. We're going to create a request handler for it, except this time it's going to send a message to the polite handler. The message is going to be an empty JavaScript object, and it's going to grab the response from that and then just write out the response to the body of the HTTP call. Cool, nice and simple, just calling a handler, done. Let's test this out. So we're going to run the same thing we did before, but with this dash cluster. So here we're going to run app.js. And Oh, there's a big error. What does that big error say? Cannot start this node, da 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 da. So Hazelcast requires a bit of configuration. This is the downside of live coding, is what a good friend Dan, who's in the audience, has coined death by live coding, is when things go wrong when you're live coding. So bear with me for a little bit while I just configure this. But this can show you the internals of Vert.x as well, in that it is running on the JVM. It is Java behind the scenes. So once in a while, in this case, you have to jump into a nasty XML file. And oh, you can't really see that, but that's OK. Grab your current IP, put it in here. Where did it go? There it is. OK, so that's that. And let's try that again. And we have our handler running over here. Cool. So those are both clustered together now. And in order to demonstrate that, I'm going to make that a bit smaller. In order to demonstrate that, I am going to run this sender.js. And all that is another bit of Vert.x. So I'm requiring Vert.x again, creating an HTTP client in this case, not a server, a client to consume HTTP on localhost port 3000. And every second is just going to grab slash and just console.log the body. So nice and simple. So Vert.x run sender.js. And that's just going to query that hello from JS, hello from JS, hello from JS. Cool. So just to give you an idea of the hot swapping that I mean here, if we were to, let's bring up another tab over here and bring up our friend Vim and bring up the handler.js. Let's say hello again from, oh, I can't spell, hello again from JS. Cool. So if we bring up another, this is the benefit of using iterm, Vert.x run handler.js cluster. So we're adding 2 of these nodes to our cluster, 2 of these verticals to our cluster. I think you know what's going to happen. So we're going to see hello from JS, going to join the cluster, handler registered, and then we can see hello again from JS. So now both of these nodes, or both of these verticals are on our cluster. We've just added a vertical, no downtime, no nothing. So this is our new code over here. Our old code, what do we do with it now? We kill it, we get rid of it. There, gone. So that's going to go away, it's gone, and what do we see? Hello again from JS. So there's a little example of Vert.x clustering, how you can cluster all these verticals together, how you can hot swap code without any downtime at all, and things just continue to work. So as I said, the telecom grade concurrency, this is really awesome stuff. And of course, since it's built on Hazelcast, it can do this across network partitions. So you can have a cluster of servers, let's say you have 5 servers or whatever, you can have one of these verticals in each one of those servers, you can hot swap them in, hot swap them out, no problem. It all just binds together over a common IP address and yeah, it just does its magic. So you don't even have to think about any of this, you have to delve into an XML file once. Cool. So that's that. Mindplosion.jpg, right? So I had this awesome picture of a synaptic explosion, but unfortunately Vim doesn't support images, so I can't really show that to you guys. But you can come up later, and I'd love to show you. Cool. So that's basically the basics of Vert.x, right? Now I can certainly do a whole lot more. I just want to go over this very quickly with you guys. Here's Chrome. This isn't Vim. So in here they have an installation guide, how you can install it. I won't get into that. Main manual. So this goes over the rest of the concepts like verticals, modules, Vert.x instances, polyglot, concurrency, golden rule, don't block the event loop, writing blocking code, et cetera, thread pool sizes and all that stuff that is really quite boring. A modules manual. So Vert.x has an awesome bunch of modules. Oh, they don't have a good SSL certificate. They have awesome modules. So these are all the modules they have for Redis, and they have a Socket.io module, a Facebook module apparently, and just a bunch of awesome modules in here that you can call and so on and so forth. As well as the JavaScript manual. So here they have more stuff, deploying, undeploying verticals, the event bus, messaging, shared data between verticals, buffers, and a bunch of stuff that is really quite boring, and you can go and look at this in your own time. Pumps and HTTP servers and file reading and all this crazy stuff. Cool. So enough of that. But one thing that really is cool is polyglot. So since Vert.x is on the JVM, it can use any JVM-based language, right? So you can write verticals in Java, in JavaScript, CoffeeScript, Ruby, Scala, Clojure, Python, Groovy. It can really go on and on and on. So if you want, you can start off by writing a vertical in JavaScript. And if it becomes a bottleneck, you can rewrite it in a faster language. So you can write Fibonacci in JavaScript. It's probably not going to perform very well. And you're going to say, hey, you know what? It's probably perform a lot better in Java. You can go rewrite it in Java, not a problem. So if you like a certain library in a certain language, use it. Not a problem. It can support all these different languages. Go ahead and use it. So for me personally, I like Ruby. So here's a little Ruby vertical that I wrote. It's also a polite handler. And it's going to require Vert.x in Ruby, register a handler in Ruby, and respond hello from Ruby. So we're going to run it in our cluster once again. So just put it over here. So we're already running our app.js, so I don't have to rerun that. Remember, we can just hot swap code in and out, no problem. We're already running our handler.js. Let's run our handler.rb. So our handler.rb is running, and once Ruby boots up, we get a hello from Ruby. Cool, hello from Ruby, hello from JS. And now we have, as I said, Ruby talking to JavaScript completely seamlessly, right? Like no real magic there. It's all handled by Vert.x completely seamlessly. So if I wanted, I can go ahead and reuse my Ruby libraries that I know and love in Ruby, pass a message off to JavaScript. It can do whatever processing there. Pass that message off to Scala. It can do whatever processing there. Pass it off as many which ways that I want, and finally respond to the client. No problem. So I can really use whatever languages, whatever libraries, whatever I want to use to really suit the problem, in the best way that it can. Cool. So just a fun little thing that I do is I use an embedded graph database in Vert.x, for example. I have that sitting on one server, and then I'll have that communicating to JavaScript on another server, and it's really quite awesome. But it's Ruby. Ruby isn't async. It's going to block my code, right? If I use my favorite Ruby library, it's not built in an evented manner. It's going to block my code. I may as well just flip this table right now, right? So what do we do about that? And just chill. What Vert.x has is Vert.x has this concept of a worker vertical. So what a worker vertical is you deploy this vertical to a separate thread pool. So you have your magic event loop. If you were to deploy that to your event loop, it's going to block your event loop. Your app's going to become responsive, and kittens will die, right? If you deploy it to a worker vertical, it's going to be completely separate out of that event loop. It's not going to be a part of that event loop at all. Everything's going to be, responsive on that event loop, and Vert.x will schedule handlers for this separately on a separate thread pool. So you can have as much blocking code as you want. As I said, I have an embedded graph database that blocks quite a bit. So I can put that on its own little thread pool, and it's not going to affect anything. And it's really still clusterable, conforms to the same API. You're just letting Vert.x know that it's going to block the event loop, so don't put it on the event loop, put it somewhere else. So, cool. So anyway, in the talks abstract, I mentioned WebSockets, and I haven't talked about that yet. So what do I mean about that? So the Vert.x has a sock.js bridge. Vert.x also has support for conventional WebSockets, and you can code conventional WebSockets just like I did with the previous HTTP handler. You just bring up a WebSocket server instead, and you just respond using WebSocket instead of HTTP. Vert.x also has this awesome support of bridging your server-side event loop over to the client via WebSockets. So what do I mean by that? So you have, as I mentioned, this clusterable event loop on your server. Now your client can hook into that as well. And it can register handlers, it can make event calls, it can send messages to your server and all of this. So anyway, here's a bit of code. Requiring Vert.x console server, setting up our same HTTP server as we did before with a polite handler. And then down here we have our sock.js server. So our sock.js server is going to respond to the /event bus endpoint. So we register our WebSockets against that. And these are our, this is here for security. These are incoming requests, so I can make calls to this handler. I can make incoming WebSocket calls to this handler, and this same handler can make outgoing calls as well to the client. So and that's for security. If I have a private vertical that I don't want to share to the client, I don't have to if I don't want to. These are the only ones that I'm going to allow. And just stepping back over here, Vert.x has this. It has a few more. Oh, where are we here? It has a few more options for this, so I can actually, oh geez. So I can actually say that only handlers where the message matches that type of, message has those fields will come through. It can do a match, so, sorry, allow any message with a field wibble with a value of foo, and you can also match on regular expression. So if you have any news handlers that that matches that regular expression will come through as well. So there's a few more options there as to the handlers that you're going to let through. Cool. So we have all this, and that's our server. So now for our client, here we're going to go ahead and require sock.js from CDN. Vert.x provides this client-side library called Vert.x bus, which is the thing that hooks up to the server-side bus. We're going to start up a new event bus here. And on that event bus open, we're going to go ahead and register a handler on our client. That's pretty crazy. When I first saw this, I was like, that's pretty crazy, as I can register handlers on a client. And at the same time, we're going to send a message to a polite handler. Cool. So let's get started with this. So we're going to run it over here, run our socket app. Oh, this is still going away. Oh, and now it fails because I killed the server. All right. Just get rid of all this. So we're going to run our socket app, and our server's listening. And over here, I'm going to open our index.html page, which is going to open this up over here. And if I bring up the console, we get a hello from the client. So that's, once again, this is going to send a message to the polite handler, which is really just defined up here, and just log that reply. Pretty straightforward, and I'll show you something kind of neat later. So now we can run our sender.js. Oh, whoops. The same sender we were running before, and that's going to once again make calls to localhost 8000, and that's going to go to the HTTP server defined in my top terminal up here. Over the event bus, make a call to the polite handler. Remember, polite handler is defined on the client. Polite handler is defined over here in the client, and come back and give that to me from the server. Right? That's pretty crazy. So a bit of background. I've been using Vert.x for about 1.5 years now, and been telling people how cool it is, and people are like, "Oh, Taz, it's built on JVM, it's built on Java. Like, what is that? No, it's not Node. What the heck?" But for reasons like this, I really come to like it because it gives me a lot of flexibility with things, and it's just so scalable. Cool. So I told you I'll show you something kind of neat. Let's start up this socket app in clustered mode, and let's start up our Ruby vertical over here in clustered mode. And let's start up our friend, the, let's just leave that. Let's leave that alone. So we have Ruby. We have a client-side application over here. Hello from the client. I forget the code for this. Let me just take a quick look. So let's just do this again. Oh, whoops. Let's just do this over here. You refresh this page. Hello from Ruby. So now I have an event bus. So if I make a call to, essentially if I just do this, I'm going to get hello from Ruby. What if I do it again? Hello from the client. What if I do it again? Hello from Ruby. Hello from the client. So that's, once again, can you guys really see that? Sorry, hello from Ruby, hello from the client. So if I just keep sending this message to the polite handler, It's going to round robin between the two handlers that I have, one defined in the client, one defined in Ruby, all going through the event loop. So moving on. That's the event bus on the client. Cool. So how do I test this? So this may not be the Vim. So this may not be the ideal way to test this. I know, like, if you're a testing guru, you're probably going to give me not the easiest time when I show you this, but it's the way that I test it at least, and it works for me. And I'm testing my code, so I don't really think you should have too much of a problem with it. But anyway, since you can define a vertical on the server or on the client, and since it's accessible from both the server and the client, who really cares where it's defined? If you define it on the server or the client, who really cares? In the eyes of Vert.x, it doesn't really matter where you define it. So, like, why not just test everything from the client? You should have client tests, tests for your client-side app anyway, trollface.jpg. But so why not just put it in that client-side test suite of yours anyway, right? Since Vert.x doesn't care if it's on the client or the server, just put everything on just test everything on your client. So if all your tests are in JavaScript on the front end, you can have front-end devs write tests that the back-end devs need to conform to. Right? All you're doing is you're conforming to this message passing API. All you're doing is conforming to, if I pass in this message, I'm getting back this response. Your front-end JavaScript devs can write tests that your back-end guys need to conform to, and vice versa. Your back-end devs can write tests that your front-end devs need to conform to, right? Like, the line becomes very blurred as to what is front-end and back-end at that point. It's all relatively the same thing, right? It's just wherever you define your actor, wherever you define your vertical. It doesn't really matter. What I do, going back to the Vert.x docs here, I use this regular expression, this address regular expression, to just be sort of like star, so really anything. So you have access to anything from your backend verticals. You can access all of them. None of them are private. They're all considered public for the purposes of testing. And this is what I do. So I use Mocha and Chai. So I have my sock.js bridge, Vert.x bus, Mocha Chai. Before each, create a new event bus. On open is done. So for you that aren't familiar with Mocha, Mocha is great for async testing. All you do is you pass in an argument, the done argument, and you call that argument when it's done. So in this case, when I'm saying when the event bus is registered, my before each is done. Please keep on proceeding. This is a bit more difficult in other testing frameworks, so I'm not sure how you'd really approach it in, like, Jasmine or whatever else you'd want to use on the front end, but it's very simple in Mocha. When I'm done, just close it. So on close is done, and just close it when I'm done. So that sets up my event bus, sets up my event loop, and I open it and close it, and that's it. Cool. So here I'm describing my polite handler. It's polite to JavaScript. I'm using that same event bus I've defined before to send a message to the polite handler. No message, and I'm expecting the reply to equal hello from JavaScript. I'm calling my done, because once again, this is async. And it's polite to Ruby, right? So I'm calling my polite handler, expecting the reply to say hello from Ruby, and I'm done, right? So the whole spiel about people that are testing gurus not being happy with this is because they'll say, hey, but Taz, this is an integration test. You're not just testing this little bit of code, you're testing the integration between your client and your server. But, like, honestly, I couldn't really care about that. I'm testing my code. You should be happy about that more than anything else. At the end of the day, I'm running Mocha, so on and so forth. So I can run all of these things. So I just want to give you a quick little demo to show you what it looks like. I'm running my socket app over here. So run that. I'm running my JS handler. Run that. And I'm going to run my Ruby handler. Let's run that. And last of all, I'm just going to open my test.html, which just opens in my browser. And we get an error, yay! So if we refresh the page, we still get an error. And do you know why we get that error? It's because I changed it. It says hello again from JS instead of hello from JS. So death by live coding. All right, let's just change that up quickly. And instead of saying hello again from JS, I'm going to say hello from JS. And let's kill this over here. Get it off the cluster. Bring it back on the cluster. And once it says that it's registered, which it does, we can refresh the page. and everything's green. Yay! Cool. So that's how I test my code, is I test everything on the client. As I said, the line between client and server becomes very blurry when you're using something like Vert.x. It doesn't really care where you define things, so why not just test everything on the client? Those are both server-side verticals. They're running on the server, but they're accessible to the client, and the client doesn't know where they are. So anyway, that's how I go ahead and test things. And yeah, that's pretty awesome. Cool. So other things I like about Vert.x, it's on the JVM. If you're not familiar with the JVM, it's a robust virtual machine. There's lots of great tools out there for how to tune it, how to, like really dig into it. There's lots of great resources. It's a solved problem. It's been out for, I think, 2 decades or something like that now. So it's been out for a while. Everyone knows how to use it. Visual VM is a great tool. I can show this to you a bit later as well. But I've heard from Node developers, knowing the internals of Node is a bit difficult, right? It's V8, which is relatively the documentation. It could not be the best. Is not the best for V8. On top of libuv, which the documentation is not the best for. On top of a Node.js API, which the documentation is good for how to use the API, but not necessarily the internals of it. So the JVM, it's a well-documented, well-known virtual machine, easy to tune, lots of great tooling out there for it. Not really the same case on Node. It's built on solid foundations such as Hazelcast and Netty. So Netty did well in TechEmpower's frameworks benchmark, so I just want to go to that quickly. I won't go through all of these because the JSON serialization depends on what JSON serialization library you use. Single query depends on what ORM you use. Multiple queries, ORM. So plain text is really where the messaging HTTP subsystem comes into play. And as we can see here, Netty, it does extremely well. So Undertow does really well, 773,000. Netty does really well, 620,000. So down here is Node, 72,000. So it's built on a really quite solid messaging subsystem as well that really performs quite nicely. And it's built with a skilled team of developers. So it's built by Tim Fox, who was previously JBoss's messaging lead. If you've ever used JBoss, it has some awesome messaging, some crazy singleton distributed clusterable messaging things. I use the JRuby version, which is Torquebox, and I really quite like it. And Norman Maurer, who's who's on the Netty core team. So these are the guys working on Vert.x. They're the guys with a lot of experience in terms of messaging, and as you can see, they've done a pretty good job. Just speaking a bit more as to Vert.x and Node, if you were to build, for example, a group chat on Node, what you'd need to do is you'd need one Node process, and you'd need to hook that up to some sort of pub sub layer. So a lot of people use Redis for this, so you can hook that up to whatever pub sub layer you want. And then that pub sub layer will then communicate with other Node processes, you do your pub sub in that way, build your IAM in that way. With Vert.x, you just run Vert.x. Vert.x is the pub sub layer. It has all this messaging, all this inter-process messaging, clusterability, all of that built in. You don't need a separate layer to communicate on. You don't have that extra layer there. There are other reasons why you'd use this. As the whole polyglot thing, I love the polyglot. I love to be able to code in other languages. Sometimes it's just a really awesome library available in another language, and just being able to use that all within Vert.x itself is really quite awesome. When you get back down to the JVM level, the VM itself is solid. You have fast garbage collectors. You can scale it past 1.4 gigs, I believe. I forget what Node's memory limit is. I'm not sure if it's still a problem or not. But you can scale it, to 64 gigs, or you can really scale the amount of memory it uses quite high. It has awesome JIT built in, awesome garbage collectors. It's just a really solid VM in general. Unfortunately, I'm not a heavy Node developer, so if any of this is wrong by any means, please yell at me. But that's just my understanding of it. Cool, and that's really it. Thanks, and that's it for the night. So yeah, thanks for coming out, and I'll see you in October at the latest.